Okay, so we just looked at doing the some kind of reference line, like a mean line and a standard deviation up and down. Next thing we're going to look at is how to do moving averages or sliding averages. Uh, and this is a pretty standard way of looking. For example, if you look in much of the literature on heart rate variability, is a nice way to to little bit get away the, because if you look here you see that the values from one night to the next or one morning to the next varies a lot, like it jumps up and down. So to try to get out some of that noise and to get more a little bit more stable values to work with that maybe catches trends over time instead, one thing that we work with a lot is this moving averages or sliding averages. So what that is basically saying, for today, take the average of the values of the last 7 days or 5 days or 3 days or 30 days or whatever you choose. Uh, so it's kind of doing like, instead of doing these averages uh, per block or per week, we just do it like for this point, do it for all, for the 7 points before or for the 3 points before. Um, and the easiest way to work with this is in R, uh, how we are working at least, is to use a library that is called Slider. Um, and what Slider does is that it gives you, and same as always, is a good idea is to go to web and just search Slider R package. Here is their own website, and here you can see all the, like, the get started, little bit introduction about what it is. You can check the, like, articles, these things, reference. Here in reference you can see all the different functions there is, and then you can read more into that when you want, but um, what sorry so we're gonna use this function, the slide function, basically. So what we do to do this is we take our data, let's see, what did we call the original data? Daily data, sorry. I Here you see an example of bad naming, because if you go back and look, I always in this project I have always tried to start, if it's a data frame, to start it with data. And here I did daily data instead of data daily or data something. I didn't start with data, which messes up then when it's time to use it. But okay, so daily data. To do this, if I look at my daily data, you see that here the good thing is that I go in order, right? It goes from 26, 27, 28. So I know that I already have my data in the correct order. But one way is always good to make sure that you have that by arranging it by date, in this case, just to make sure that you actually have the rows after each other. So that's the good way. And now what we're gonna do is we could look, for example, this time at our wellness. So we have our Hooper index, and we have our SRSS, recovery and stress. Let's look at these three, for example. So what we're gonna do is we're gonna take we start with 1 just to show. Let's take the SRSS recovery because it's the first one. So then what we want now is we don't summarize because we still want one row for each day, right? We just want to change the value to not only be today's value, but the average from before. And if you remember from last week, we did something similar. Last week we used the one that is called, so if we would put this as, we used the lead function. So there is this lead and lag, which basically takes the previous or the next value. And here we should probably use the lag because we probably want the, so we want the lagged value. Again, we're not now showing you the first step. We're not actually looking at the moving average right now. Just to show you the first step is that we can work with these kind of functions to take values from rows below or above. So we would say like lag. So for SRS's recovery 2, just to show you, we want to take the value from SRS's recovery, and then we want n, in this case, to be, for example, 1. That is, take the value 1 row above. And if we could make it easy here and just select date, SRSS recovery, and SRSS recovery 2, just to show you we don't need to see all the other variables for now. So we have a look at this, and now you will see our new one here, SRS's recovery 2. For the 27th of April, the value is 19, which in the original is the value from before. Next one, 15. So you see here that it takes like it. So doing lag 1, and again, I think last week I did this wrong because I used the lead, not the lag, which it's important to be careful with the details. And you make mistakes and you then need to go back and fix that. That always happens also. But you see that the lag function takes the value from one step before. And if we use n equals 1, if we would use n equals 5 and run this, then you will see here that we have for the 1st of May, we should have the value from 5 days before. 1, 2, 3, 4, 5 days before. Correct. The first days we don't have anything because we don't have any values before here. So we can't take, what is the, for the 29th of April, what is the value from 5 days before, 5 rows before? 1, 2, 3, we don't have 5 rows before, so it's missing. So this is how you work with these kind of functions. But the one we're looking in now, and we can keep doing this. A good way just to check that you calculate things good is to create a second version and just compare of a variable. Just compare the first one to the second one until we know that we have things correct. So what we're gonna do now is instead of the lag, we're gonna do slide. And we look at the help. So we're using a sliding window. This is just the thing of saying take values from before or after, but not only one value. Take several values. Apply F to each sub window of X. So here is where it gets a little bit more messy, because obviously if we take so we're gonna want for SRS's recovery 2, we want SRS's recovery. Now if we just run this, sorry, we can run it this way just to show you, we get a problem because the function here is missing. So we need to apply a summary function. So think about the slides here as summary, doing like the typical summary function, but for only the rows before. And in this case, the function that we want is the mean, right? We want to take the average. So we could, and here typically we don't write these ones out, the names of this. We just do like X and F. We run this, and now we see that we have the values are just the same, right? Okay, why is this? Again, we go back in to look at the help page and we look at the default value. So for slide, the default before and after is 0. The L here is just to say that it's integer, like it can only be it can't be a decimal, but before and after is 0. Probably this has something to do with it. We go down, before and after. The number of values before or after the current element to be included in the sliding window. Here, in this case, we will need to set, for example, the before value. And if we want to do let's do a first 1 week, so 7 days. So we do 7. And we run this and see what happens. Okay. First one is 19. This is just the first value. So here it doesn't take 7 values. Next one is 17. That should be the average of 19 and 15 is 17. So correct. And then it looks like this keeps going. So we have 1, 2, 3, 4, 5. And then we have NA, so we have missing values here. Okay. And then how do we, because here we just put mean, we didn't actually put do the function of it, right? So here we're gonna need to go down and check how can this work. Okay, we need to scroll, see if we have an example, and no, we actually don't. So okay, we didn't actually see a good example here, but the typical way to do this is to do \x. This is a short way of saying create a function. And now we're doing, this is a bit of a extra course. If you don't want, you don't need to, you can just accept that this is the way to do it. And if you want to read more about it, you can read about anonymous functions. So this is called an anonymous function. So we basically need to create a function that consists of this function already. But we say take the mean of x, that is what we said in here. And then we want the NRN, like the remove missing values, to be true. We try to run this now, and sorry, this is the other kind of slash. This way it's supposed to be. It's supposed to be this way around. Okay, we run this, and now you see, now we do have values everywhere. So it just ignores these missing values, right? Okay. Good. Couple of things. First of all, if we have a 7-day rolling average, we probably don't want these first days because we don't have enough data to actually calculate. And typically, if then you have a 7-day average, but the first values only take the mean or the average from here in this case 1 day, and here in this case 2 days, is going to shift a lot more up and down than the rest. So then we have a look, slide help. Okay, which kind do we have here? We have one that is complete. Could this be something? We can check here. Complete. Should the function be evaluated on complete windows only? And in this case, complete means the thing of like, if we say that it should be 7 days, does it actually take 7, or does it only, or like a complete window is when it has 7 values. So let's try this one. We do complete true, and we run this, and now you see that here is true. We don't have any values for 1, 2, 3, 4, 5, 6, 7, and then on the 8th we do have. So this is good. This is what we want. And actually, now we see a problem here. We should have one on the 7th day, right? 1, 2, 3, 4, 5, 6. On this day, we should probably have a complete one here. So let's scroll down and see if we see something about that. We see if we see anything more about complete. Complete controls whether or not partial results are computed. By default, they are by setting complete true, restricts slide to only evaluate the functions where a complete window exists. Okay, that one didn't give us any more info. Then the other option here, what it could be, is that the before, so this one is a bit confusing. Before and after, it says how many. So here we said where do we start, and this is where we finish. So in this case, we finish with the same day, right? Because the after is set to 0. So it sets for the same day. One option here could be that we actually need to do, let's try to do before 6. And if we now double check here, so we have 1, 2, 3, 4, 5, 6, and then on the 7th we do have a value. And now let's check if this value matches 1, 2, 3, 4, 5, like 1, 2, 3, 4, 5, 6, 7 days. So let's actually just hand calculate this. We do 19 plus 15 plus 13 plus 14 plus 18. Then we have one that doesn't have anything, and then we have a 19. Okay, and this we should divide by 7, right? 1, 2, 3, 4, 5, 6, because we have one missing value that we said just ignore that one. Divide by 6, 16.333. This is correct. So, this is the correct one. And this, if you think about it, it actually makes sense, because this one says how many days before, right, should we include, but this is only the amount of days before the current one, the current row, but we include the current row also. So this value needs to be one smaller than the lag window we actually want. So this is one way to work with this. There is actually a little bit easier way to work with this, and especially one that you are going to need to do if you don't have values for every day. So if we have a look here at the help page for the slider, and then you see here that we have slide is the one we used, and that just goes by rows. Then we have two other versions, slide index. Here you see it's the index, in this case our date, is irregular. So we jump. So there are some missing, like 29, 30, and then it jumps to the 3rd. So, and these are actually days that we want to include. If we want a 7 days rolling average, we actually want to include this. Like, we don't want 7 rows, we want 7 days. So here, what compute a 3-day moving average, and this should be different since we actually have some days that are not in the data set. So if we just use the normal slider that we did, it's just going to take the 2 days before and the same one. So we could use the sliding index instead. And again, here you can read more about it. And then in this case, we say slide index, and then you can use this kind of days. So we want 2 days before. And then we can also use the slide period. So if we again scroll down here, and this one I think it gets a little bit more complex to work with. So in this case, we could probably try to use our slide index. And if one option here is to look, do we actually have this case somewhere? 26, 27, 28. Here goes each day. Here, you see the 18th of May, and then we jump to the 20th of May. So if you actually do the counting this day, the 20th, if we do a 7-day rolling average, we should have, we're going to take 1, 2, 3, 4, 5, 6 rows before, but this is actually more than 6 days before. So we get more than a 7-day rolling average. So this value, for example, should change now if we use the slide index instead. Just to double check, we could actually do a SRSS recovery index. Again, here, just to double check that we're actually doing the things, that everything gets correct. So now we'll do a slide index. We check the help, and the slide index has one more argument here. That is the I. So the I, if we check here, this is the index. So in this case, our date. So first one, .x is the same, SRSS recovery. The next one is our date, because date is the index, so it's where it looks like how many before or after are we doing. Then our function is going to be the same again, our mean. And now, if we try to run this, sorry, take the complete true also. We try to run this way and see what happens. And now we just double check here if we have here, you see, here we start to get a difference, because this one is the one that is incorrect, because it doesn't take into account that the 19th is missing. So this one would be the average value of this 1, 2, 3, 4, 5, 6, 7, which is one too much. This shouldn't be included because it's the 8th day behind. Whilst this value should be the average of 1, the 19th that is missing. So this is then the 3rd. 3, 4, 5, 6, 7. So this is more correct. So we should use this one instead. So we can we take out this one. Now we use the slide index instead. Again, you could use slide index. You could use the slide period as well. If you're interested in looking more into detail on this, go in and look at that. But same here, we could do. So we could do slide. This is a 7-day. We could just double check here. Let's say that we want to try to do one that is maybe 3-day. So then we'd use 2 before, right? And then we say we want to look at the 7-day and we want to look at the 3-day. We run this, and now you see that here we start to get values on the 3rd row, which is for a 3-day rolling. That's correct, so good. And here we get on the 7th. So this is how we can work with creating the sliding windows. So let's actually do, let's start to look at how this looks when we plot it for just one variable. Then you can do this for several variables. We can look at that, but let's do data, wellness, sliding, for example. Then we take these, we do ggplot, aesthetics. We're gonna have the, if we start here, the X value is gonna be our SRS's recovery. No, sorry, X is date. Y is our SRSS recovery, and then we add them as points, and we have a look. And here you see this that it goes up and down a lot, right? One thing that we let's fix already from the start. You need to really consider which is the scale that is valuable to show here, because here you see that it by default it basically shows from the minimum to the maximum observed values. But in this case, this doesn't make sense, because this is only a small part of what you can actually. Here it looks like, oh, this day is horrible, but is it actually horrible in reference to how the scale is considered? Like, what is the minimum? Normally what you would want is show what is the, especially for these kind of indexes, what is the minimum and the maximum value possible. And if we check, I think I wrote it in here actually. So each subscale is downweighted sum of 4 items. It ranges from 0 to 24. So for the SRSS, it would make sense to have 0 to 24 as a scale. For Hooper, 4 to 28, which, if we think about it, is the same as 0 to 24 if we just subtract 4 from it, and then we would have all on the same scale. So that would help. But in this case, 0 to 24. So it would probably make sense here to say the scale Y is continuous, and then we could do the limits. So we would want to set the limits, and then you need a vector with first the minimum and then the maximum. So we wanted to go from 0 to 24. We look at it now, and now you see that, okay, this is the minimum possible value and this is the maximum possible value, and it shows a little bit more because, and in this case we could actually remove it, because if you take here scale Y continuous, and then we check that there is one that is expand. If we look at this one, it actually, what it does is by default it expands this range a little bit to show. So if you look, for example, here, even though we put 0, it goes a little bit below. Now you can look more yourself into this, and you see that there is a convenience function that is called expansion. So we could just put limits expand, and then we would do expansion, and in this case you can do either a multiplication, so you multiply, or you just add, and again, read more about it. In this case we want nothing, so now you see it goes from exactly 0 to exactly 24, and now you see here that the range of values is much less up and down, right? Good. What we want to do now is, so we have our points, but now we probably want to add a line, right? And this line, we want it to take the value from, let's start with our 7-day recovery. So we want our y value to be the 7-day recovery. We run and get a problem. Okay, now let's look at this, what is happening. And actually, if we look here, data wellness sliding. Okay, data wellness sliding, and we check. Okay, this one looks different, right? List of 42. So this is not a numeric or character. This is a list format. Okay, what is happening here? Probably, let's check in the help here. Here you see that you have a bunch of different versions, and if you go in, and again I recommend go in and read the help page, go to the web page. What this does is, seeing it doesn't actually convert this into a numeric variable by default. For that you need to use this version. So we're going to use slide index double. Using slide index double, we run this, and now you see when we look at the data that they are normal numeric variable. So if we run this now, we see that now we get a correct one. And so here you see our 7-day rolling average, right? And then we could actually, if we want, we could just compare here to see how it looks. If we copy this and we paste it and we do our 3-day value average, since we actually calculated both. And then we can do here, we could do a color red and a color blue. Again, we put it outside the aesthetic because it actually doesn't map to the data set we have. We just explicitly set a value. And now you can see that the 3-day average goes up and down more than the 7 days, which makes sense that the more days we have, the more the less is going to move. So if we would here take a 6 weeks or like 60-day average, it would just be a straight line, right? So this is how you can work with moving averages. So if we again just look at the 7-day, one thing we could add here is we remove the 3 days, but instead of having the only the mean, we maybe want the standard deviation as well. So we can just take this, add here, now we say 7 days mean, or M, and 7 days standard deviation. And then here, instead of mean, we do standard deviation. We run this, we check the data, and then you will see here in the end, we have our 7-day, the mean, and the standard deviation. And then we could do again, as we did before, we do a low or lower, which would then be to show this in the plot. Then we would want the 7-day mean value minus half of the standard deviation, and then we do the same for high, but here instead of minus is plus. we save this, we just double check that we have it here, lower and higher, which are, as you see here, we sum up, we just double check that it makes sense. This value should be this value minus half of that, and it's correct, and so you check like that. And then now here we would add, we can take this out. Here we would then add the geom ribbon. In the aesthetics, we would say that the y min is the lower, and then the y max is the higher. Remember the plus. Here we say that the y value should be the SRSS recovery. In the line, SRSS recovery 7 days, but since we added the mean and standard deviation, now we don't have the 7 day. It should be with a M. So we run this, and now you see that we get like the standard deviation here as well, to show you a little bit of, and again probably we would do something like alpha 0.5, not to the line, sorry, not to the line, to the ribbon. We run this, and now you get a 7-day rolling average here. We could even do something like, if we're interested, we could even here add again some color and fill. So we could do the and again you could do here color equals training block. Now you have the problem here that they are the same as before. We have the lines, not the, so we need to do in the geom ribbon here. Now then we would do color nothing, but the fill equals the training block. This should be null this way. So now you get, if we look at this one, now you could get the rolling average by training block, for example. So this is the way to work with rolling averages and standard deviations. Again, you can try shorter periods, you can try longer periods. And this one, if we want to do this for several variables, we can do that. The easiest way to do this now then would be to take our daily data, and the first, so we're gonna do, we could actually do this below, rolling average all wellness. So then we would take our daily data, we would pivot it longer like before, and now we would say that we would take SRSS recovery, we would take SRSS stress, and we would take Hooper, and we say names to variable. So we just double check that it looks correct. Here in the end we have our 3 variables, and then we have our values. Perfect. Now the only thing to think about here is we probably want to arrange it so we have all the days of one variable first to do the sliding window function. So here we would need to arrange, and before we did it by date, now we want to do it first by variable and then by date. And if we look at this now, you see that now we have 26, 27, 28 for our Hooper, and then after that we have SRS's recovery, and then after that we have SRS's stress. So this is good. And now we do the mutate, and then we would do so we would have like we could maybe call this mean 7 day if we work with a weekly, and then we would say slide index double, and then we would say that we want to take the value column, right? Remember that when we pivoted longer, if we look at this one, our actual values that we're interested in, it's just in the value column. One more thing, sorry. Apart from arranging here, we actually need to group by variable, because what we don't want, if we look at this one, if we don't group by variable, then here it just takes the 7 values before, which means that for this here, it would take this plus this plus this plus this plus 2, 3, 4, 5, 6, 7. So we need to tell it that do this by each variable, so the first values from SRS's recovery doesn't take values from above. So we group by the variable, and now we run our value. The date is our index. We can go up here and check. This one we could actually just copy. We want our mean, blah, blah, blah. We can always just double check that. We have this view here left. We run. Argument F is missing. Why is that? So we just check that it should look the same as here. Slide index double, SRS is, so this would be our value, date, the function before complete. Slide index, value, date, mean before. Why is this not running? Sorry, this okay, this it has the index 2. That's to use to combine several columns. That's a more complex function that you're not going to use. Sorry, that's the problem. We run, we just double check, and this should be the same now for the SD. Just that this one should be SD instead. We can run this and just view it to double check that we have mean and standard deviation, perfect, and it comes from the 7th day. Apart from that, we just do lower 7 day, should be the mean minus half of the standard deviation, and then we do the same for the upper, but it should be plus. We save this into data wellness. We could call it data longer. I normally call it when we pivot something to make it longer. Wellness 7 day. Okay, we run this, so we saved it, and now we're gonna do the plot basically the same way with the data longer wellness. The difference here, remember that we're gonna need to do a facet wrap or a facet scale, whichever one. Do a tilde, and we want to split it by variable. And we don't use SRS's recovery here anymore, because so the y is supposed to be value, and here it's supposed to be the here is supposed to be the mean 7-day, here is supposed to be the lower 7-day, and here the upper 7-day. We run this, and now you see that we get 1 for each scale here. Here's a problem. We did set the scale from 0 to 24. This is a problem. This is one negative side of doing several different variables, that it's hard, it's possible, but it's very hard to set specific scales for these different ones. So you see that even the Hooper that should go from 4 to 28 is right now on the same scale as these ones. One option would be to take the to put the Hooper on the same kind of scale. Which would be to take out 4. So we could do that if we want. But that's how you do sliding windows.